Yeah, let me share the screen, and I would say, Eric, the stage is yours.
Thank you very much, Marianne. Thanks a lot also, Ming, for this very powerful message. So Ming is a chief engineer in Altair. It's a recognized scientist working on optimization on many things, OpenRadioss Radioss, and this show how Altair is committed to OpenRadioss. And so welcome today. Welcome to your day at the OpenRadioss Users Day 2025. So I will try to be very brief, but to give you a short update of what's going on with OpenRadioss. First, I want to thank our sponsors, so Altair, Aptus Data Points Lab, ARM, Cornelis Network, and Viper Applied Science, and our host, Chalmers University. And these are more than sponsors, they are partners. We are working with them, and you will see during presentation today that they are also committed to OpenRadioss. And also with Chalmers, we are really happy to be part of the Silo conference. I hope that you would also extend your stay to stay also for the main conference. And there is an awesome program. I think that there will be also OpenRadioss focused on the Silo, okay? And we are really happy to be there also for the collaboration that we have with Chalmers, which is really exciting. We'll have a talk about that today at Users Day. So just for those that do not know OpenRadioss before or Radioss before OpenRadioss, Radioss is in the industry since more than 40 years, almost now. And it's a really proven code used in car crash, but also in aero and defense for blast and all sorts of high-end explicit dynamics simulation. But also in the consumer goods, in let's say manufacturing and sport industry, healthcare, and so on, with the democratization of let's say computer science and progress in the computer science, because it's explicit, so it's really high demanding CPU code, so you really need to have the power to run it. At the beginning, it was only on big computers, and now you can run it even on a Raspberry Pi. Okay, and so as Ming explained, and as you have seen in the introduction of the video today, our goal when we started to OpenRadioss with OpenRadioss, it was really to democratize the explicit dynamics. And we see now that we are building this energetic, active community, and it's really great to see after less than 3 years where we are today, okay? And this was our goal, but I mean, we see already today that thanks to open source, we are also bringing a lot of innovation into the code. And this is really exciting moment. We saw a very good answer at the day of launch, because I think we were, let's say, pioneer in that direction, the first explicit code to become open source, or large code to begin open source. And I think that this was also a very good vision of Jim Scapa, former CEO of Altair. And since then, we see that there is a growing adoption with more than 16,000 downloads. It's huge for such kind of application. And we are really helped by the steering committee. And you will see today Elan Sarai, Paul Dubois, that have made the travel from the US to come here. Also Nicolas Valino from Safran, that is here, okay, Nicolas, yeah. And I also want to thank Georgios Michaloudis, that just joined the steering committee a few months ago, and which is already very active with the Bundeswehr University to contribute to OpenRadioss. And also I want to address my thanks to Kang from Simrite. So Kang helped us a lot to build also a webinar in China, which was very successful. Marianne, I think that you spent 12 sessions, something like that, more than 500 slides to present. And there is a strong, let's say, ramp up of OpenRadioss in China. You had more than 50 universities attending your talks, and it's exciting to see also how it's growing in this country. And yeah, so that's very good moment for Radioss. I mean, in less than 3 years, we have been able to set a lot of collaboration on partnerships Sorry for those that I missed, but I mean, this is just to give you, and you see that you retrieve our host, our sponsor. So this means that really we are engaged all together to contribute to the code and to extend the capability of the code. What is important also to know is the relationship between OpenRadioss and Altair Radioss. So we decided to go to dual license. So this means that, yes, OpenRadioss is here. This is the benefit from open source. It is free for all. It is the best tool for collaboration, for R&D. It is continuous integration and continuous development. This means that you can try. Thank you. You can try, let's say, development, and we can work together with partners, with developers, with testers. But at the same time, I mean, this is also important to keep a very strong, very professional code. So also OpenRadioss benefit from Altair Radioss for 40 years of development and for the fact that we are committed to stay a very professional code. So that's the reason why each contribution, whether it is coming from the internal team or from the community, it is maintained and accepted by professional maintainers. So we really keep a very strong code, very efficient, very professional. And for commercial users, they benefit from the commercial, let's say, the professional support of the commercial version. And this is very important for some users, while for others, they really want to have something open, something where they can work together to address new challenge, because challenges are high. There is no more low-hanging fruit. We need to do really great development to be able to address the current need and the future need in the industry. And all together, we are more strong. Okay, so one important point with open source is that, yes, Radioss is very well integrated with all the Altair tools from HyperWorks, HyperMesh, for meshing and for pre-processing, the HyperStudy, Physics AI, ROM AI, all those tools that are, let's say, able to take advantage of AI technologies. But at the same time, we need to be also open towards standards. So that's the reason why we put a lot of focus also to be able, with Radioss, to run, let's say, input deck in LS-DYNA format. So one example, collaboration with Chalmers University and Graz University. This is the Viva Plus model. This is an open source human body model, and this is in LS-DYNA. You can take it from the OF2 website and just directly launch it and run it with OpenRadioss or Radioss. This is working. Okay, so this is the type of things that we do to facilitate and to have, let's say, more broad adoption of OpenRadioss, larger community, being able to run also those models that are here since many years in the industry and in the R&D. Also, I want to thank a lot also Alexander Sadowski that approached us and with the ambition to go even further in the democratization of Crash Code. He said, yeah, I am from the FreeCAD community, how to use OpenRadioss with FreeCAD. And then the answer was addressed by my colleague Paul Sharp. He developed a so-called IMP to RAD converter that takes Abacus or Calculix input deck and be able to convert on the fly through Python to Radioss format. And thanks to that, Alexander was able to demonstrate this fully workflow open source from FreeCAD, PrepoMax, OpenRadioss for the simulation, and then ParaView for the post-processing. So this is amazing, and this is really aligned with the vision to democratize explicit dynamics and to have this large community being able to do it with, let's say, non-linear explicits. So I wish good luck to Alexander in his commitment to promote that. And this is really someone which is full of energy. I think that he made a workshop in Altair also. He presented at CARS. So yes, that's great. And I hope that it will also push more users toward the commercial version, because at the end, after, let's say, trying the open source, at some point, going to the commercial version and to use professional tools is something to go to the next step. Okay, one point is that with Radioss, we provide high-end dummies, okay? But let's say those dummies are, let's say, collaboration with partners, and they are proprietary. So they are restricted to Radioss commercial version because they are encrypted. So to be able to do also biomechanics and R&D with OpenRadioss, we decided to give to the community our legacy dummies. Okay, so those the dummies that were, let's say, no more used, we decided to put them to the community on model exchange. So this is a GitHub branch where you can put models, when you can take models. Really, we call them community dummies because we envision that with your help, we will be able also to improve them. So the same time that we can improve the source code OpenRadioss, we can also work with models and to improve models. And this is the idea behind that. So my call to action is contribute to model actions. If you have public models that you want to deliver to the community, that's a great place. And then the community can work together. Student, professor can use them for their teaching. So it's very important. And this is something that I think there is, let's say, some way to do better and to do more. But for the moment, I think the dummies is very good. And I encourage you to test them and to give your feedback about those dummies, and we will complete the suite. Another point is that we worked recently to make this reader fully open source. Before we use, let's say, some closed source library to do the bridge between Radioss deck or LS-DYNA deck reading CFG file. So I don't want to enter into detail. If you have questions, you can come back to me later. But basically, is this branch, this module was, let's say, closed source, and we were able to refactor the code, and now it is available open source. So I can claim that now the code is 100% open source. Okay, so that's great for people that want to port to exotic platform and to contribute. I think that it will also help the contribution of people that are writing new things into the code to have the vision, let's say, the access to the full code. So yes, I know that in the community is running fast and people are already using that. So they found the magic flag minus OpenReader to use this new reader, and it will become the default soon after the final validation. So please, if you have, if you want to test it, you can test it, and I will be really pleased to have your feedback. Another point is that yes, to fill the gap with the fact that we are really, let's say, compatible and can interoperate with LS-DYNA, where there was a missing piece, that is the output. And a great guy, David Russell, from Vortex CIE, he brought the solution to the community. He was able to expand the so-called last of Python to include a reader of animation, so the file format of Radioss, and to convert it on the fly to D3 format, the format of LS-DYNA. So he was able then to replace this solver by OpenRadioss. It was one of the first adopters of OpenRadioss just right after the launch, almost 3 years ago. And on my internal team, we have purchased the work in order to add, let's say, more output to this tool regarding solids and SPH. So this will come very, very shortly. And just recall that this tool you just can enable by a switch on the compute console that we offer with the OpenRadioss. So very easy to use it. Last point, last year at the Philadelphia meeting, we introduced the stable build. So this is a way to have even more stability even for the open source version. So to avoid regression, because it's continuous integration, we decided that the open source is updated continuously, but the executables that we provide are updated only after they pass more tests. So that was the idea behind to have, let's say, more stability, more robustness in the open source. And we did also a magic button. So when you download the executable, please share your feedback. This is helpful for us, but also helpful for you. If you see something that we need to improve, something you are happy, something you are unhappy, I mean, all the feedback, we take it and we appreciate a lot. So please do take a minute or two to feel that. This will be very helpful for us. We also added the ARM platform. So now if you are running on ARM, which is an increasing platform for running explicit code and compute-intensive code, you can do so. You do not need to recompile a specific version. You just take the executable asset and you run it. So let's see it here. So yeah, I don't want to be more longer. I mean, we have all the day. We stay here also during the other days of the silo, so we'll have a long time to exchange. I have my team here, so Marianne, of course. We have also Thierry and Adrien. They are really good experts, so please feel free to reach out to them with your question during this day and the other days. And yeah, I mean, this is your day, so enjoy your day. And I hope that we will have a very interesting and insightful presentation. So I don't want to do more, but I will be able to address your question during the pause and after. Okay, thank you very much.